US Physics Olympiad, year 2018. F equal MA. Exam B. In this year, this exam was splitted by 2 different days, and you can participate either in day A or day B. That was the same condition for participation. 25 problems for 75 minutes. Please subscribe for this channel to get more interesting problems. Problem number 1. A large lump of clay is dropped off of a wall and lands on the ground. Which graph best represents the acceleration of the center of mass of the clay as a function of time? Problem number 2. A uniform block of mass 10 kg is released at rest from the top of an incline with a length 10 meters and inclination 30 degrees and slides to the bottom. The coefficients of static and kinetic friction are mu static equal mu kinematic equal 0.1. How much energy is dissipated due to friction? Problem number 3. A 3 kg mass moving at 40 meters per second to the right collides with and sticks to a 2 kg mass traveling at 20 meters per second to the right. After the collision, the kinetic energy of the system is closest to. Problem number 4. A basketball is released from rest and bounces on the ground. Considering only the ball just before and just after the bounce, which of the following statements must be true? Problem number 5. The hard disk in a computer will spin up to speed with 10 rotations, but when turned off, will spin through 50 rotations before coming to a stop. Assuming the hard disk has a constant angular acceleration alpha 1 and the angular deceleration alpha 2, the ratio alpha 1 over alpha 2 is next one. Problem number 6. A massless beam of length L is fixed on one end. A downward force F is applied to the free end of the beam, deflecting the beam downward by a distance x. The deflection x is linear in F and is inversely proportional to the cross-section moment I, which has units meters power 4. The deflection is also depending on Young's modulus E, which has units newtons per square meters. Then x depends on L according to next one. Problem number 7. A pendulum of length L oscillates inside a box. A person picks up the box and gently shakes it vertically with the frequency omega and the fixed amplitude for a fixed time. To maximize the final amplitude of the pendulum, omega should satisfy next value. Problem number 8. The coefficients of static and kinetic friction between a ball and the horizontal plane are mu s equal mu k equal mu. The ball is given a horizontal speed but no rotational velocity about its center of mass. Which of the following graphs best shows the rotational velocity of the ball about its center of mass as a function of time? Problem number 9. A 3 kg ball moving at 10 meters per second east collides elastically with a 2 kg ball moving 15 meters per second west. Which of the following statements could be true after the collision? Problem number 10. A balloon filled with air submerged in water at a depth h experienced a buoyant force B0. The balloon is moved to a depth of 2h, where it experienced a buoyant force B. Assuming the water is incompressible and the balloon and the air are compressible, the buoyant force B satisfied next conditions. Problem number 11. A circle of a rope is spinning in outer space with an angular velocity omega 0. Transverse waves on the rope have a speed v0 as measured in the rotating reference frame where the rope is at rest. If the angular velocity of the rope is doubled, the new speed of transverse waves as measured in the rotating reference frame where the rope is at rest will be next one. Problem number 12. A child in a circular rotating space station tosses a ball in such a way so that once the station has rotated through 1/2 rotation, the child catches the ball. From the child's point of view, which plot shows the trajectory of the ball? The child is at the bottom of the space station in the diagrams below, but only the initial location of the ball is shown. Problem number 13. Two blocks of masses M1 2 kg and M2 1 kg are stacked together on top of a frictionless table as shown. The coefficient of static friction between the blocks is μs equal 0.2. What is the minimum horizontal force that must be applied to the top block to make it slide across the bottom block? Problem number 14. A spool is made of a cylinder with a thin disc attached to either end of the cylinder as shown. The cylinder has radius r equal 0.75 cm and the discs each have a radius big R equal 1 cm. The string is attached to the cylinder and wound around the cylinder a few times. At what angle above the horizontal can the string be pulled so that the spool will slip without rotating? Problem number 15. You are standing on a weight scale that reads 700 newtons while holding a large physics textbook that is originally at rest. At time t equal 1 second, you begin moving the textbook upward so that by time t equal 2 seconds, the textbook is now half a meter high and once again at rest. Which of the following graphs best illustrates how the reading on the scale might vary with that time? Problem number 16. A plane can fly by tilting the trailing edge of the wings downward by a small angle theta, called the angle of attack. In still air, a plane with a ground speed v will have a lift force proportional to v squared theta, and the drag force is proportional to v squared. Consider a plane initially in level flight in still air with a constant ground speed v. If the plane enters a region with a tailwind with a speed w less than v, the wind is blowing in the same direction that the plane wants to fly. How must the engine power and the angle of attack change for the plane to maintain level flight at the same ground speed? Problem number 17. A pogo stick is modeled as a massless spring of a spring constant K attached to the bottom of a block of mass M. The pogo stick is dropped with the spring pointing downward and hits the ground with the speed v. At the moment of the collision, the free end of the spring sticks permanently to the ground. During the subsequent oscillations, The maximum speed of the block is next one. Problem number 18. A spring of a relaxed length L1 and a spring constant K1 is placed in parallel with the spring of a relaxed length L2 and the spring constant K2. A force F is applied to each end. The combination of the springs acts like a single spring with the spring constant K and the relaxed length L, where we have next expressions for K and L. Problem number 19. In an experiment to determine the speed of sound, a student measured the distance that a sound wave traveled to be 75 plus minus 2.0 centimeters, and they found the time it took the sound wave to travel this distance to be 2.15 plus minus 0.10 milliseconds. Assume the uncertainties are Gaussian. The computed speed of a sound should be recorded as following. Problem number 20. A massive uniform flexible string of length L placed on a horizontal table of length L over 3 that has a coefficient of friction mu static equal 1 over 7. So equal length L over 3 of a string hang freely from both sides of the table. The string passes over the edges of the table on smooth, frictionless, curved surfaces. Now suppose that one of the hanging ends of the string is pulled a distance x downward, then released at rest. Neither end of the string ever touches the ground in this problem. The maximum value of x, so that the string does not slip off of the table, is next one. Problem number 21. A uniform bar of length L and mass m is supported by a fixed pivot, a distance x from its center. The bar is released from rest from a horizontal position. The period of the resulting oscillations is minimal when x equal which one? Problem number 22. Two particles of mass m are connected by pulleys as shown. The mass on the left is given a small horizontal velocity and oscillates back and forth. The mass on the right will behave like this. Problem number 23. Two particles with mass m1 and m2 are connected by a massless rigid rod of length L and placed on a horizontal frictionless table. At time t equals 0, the first mass receives an impulse perpendicular to the rod, giving it speed v. At this moment the second mass is at rest. The next time the second mass is at rest is next one. Problem number 24. A particle of mass m is placed at the center of a hemispherical shell of radius r and mass density sigma, where sigma has dimensions of kilograms per square meter. The gravitational force of the shell on the particle is next one. Problem number 25. A student is measuring the surface area of a cylindrical wire. The student measures the radius of the wire to be 1 plus minus 0.1 centimeters, using a ruler, and the length of the wire to be 1.00 plus minus 0.01 meters, using a meter stick. The precision of their results can be increased in several ways. First one, upgrade the ruler to a caliper with uncertainty 0.01 centimeters. Second one, upgrade the meter stick to a tape measure with uncertainty 0.001 meters. Third one. Repeat the measurement independently 10 times and average the results. How do the resulting uncertainties of the measurements compare?